State Archimedes principle. I will not write. You can write it by using note. Archimedes principle. If an object is fully or partially immersed, if an object is fully or partially immersed, in an incompressible fluid, upthrust on the object is equal to the displaced fluid weight. Again, Archimedes principle. If an object is fully or partially immersed in an incompressible fluid, upthrust on the object is equal to the displaced fluid weight. Then explain why is it easier to float a uniform cylindrical body horizontally in a liquid than vertically. How can this cylinder be made to float vertically? We can draw some diagrams to explain it. When considering cylindrical object which is immersed in a fluid, weight is acting from the center of gravity. Upthrust is acting from the center of buoyancy. It is like midpoint of immersed part. Therefore, if the object is inclined like this, weight is in this action line and upthrust is in this action line. Therefore, it is trying to rotate. Then it is difficult to float vertically. If there is a small horizontal angle, it will rotate due to this opposite forces acting in different action lines. Then we can write it is an unstable equilibrium. We know that there are three types of equilibrium: stable equilibrium, unstable equilibrium, and neutral equilibrium. This object is at an unstable equilibrium. Therefore, it is difficult to float in vertically. But when considering this one, object is horizontal. Gap between center of gravity and center of buoyancy is a small value. Therefore, it is easy to float in this method more than this one. Then we can write gap between center of gravity and center of buoyancy is a small value. Therefore, we can float easily. If we have to float the object vertically, we can use a heavy mass for the bottom of the cylinder, like this, heavy weight. Then we can write, we can float easily, float vertically by using a heavy weight. At the bottom. At the bottom. Then next part, describe how such a cylinder can be used to determine the relative density of a liquid. We can immerse corresponding cylinder in corresponding liquid and water separately, and we can measure the immersed depth of cylinder. Immerse cylinder in water and fluid separately and measure the immersed depth. Then we can get, if an object is immersed in water like this, immersed depth HW, density of water rho W, we can write upthrust on object equals weight. It is according to the floating principle. Then we can write upthrust is V rho G. When substituting V, we have to substitute immersed volume. Immersed volume is cross-sectional area into height. Density of water, we can cancel out G equals M. It is the first equation. Then we can consider corresponding liquid, and we can immerse same cylinder in corresponding liquid, and we can measure this HL depth, height of corresponding liquid. Again we can write this equation, cross-sectional area into HL into density of liquid should be equals to M, second equation. Now we can identify there are two equations, right hand sides are same. Therefore, we can equal left hand sides of two equations. And we can write AHW rho W equals to AHL rho L. Then we can cancel out A and A. Relative density means density of liquid divided by density of water. We can subject it by that equation. Then next part. A pan of water is suspended from two spring balance X and Y. As shown in the figure, a block of brass is suspended from third balance Z. Z should be the middle one. X and Y reads 1 kilogram each and Z reads 1.2 kilograms, when the block is gradually lowered by increasing the length of string so that it is completely immersed in water as shown by the dashed lines. Image is not clear. You can't identify dashed lines. I will explain it. The balance Z reads 0.8 kilograms. Find the new reading of X and Y. For the initial situation, it is like this. There is a water pan. Reading of X is, I will consider Rx. Reading of Y is Ry. For the initial situation, this block is immersed with, not immersed. Therefore, it is Rz. Rz reading is given as 1.2. Rx 1 kilogram. They have given all values in kilograms. This one also 1 kilogram. For the second situation, this block is immersed in water. After immersed, reading of Z is, I will consider Rz dash 0.8 kilograms, and Rx dash is new reading, Ry dash is new reading for this one. Now we know that this reading difference is due to the upthrust on this one. Therefore, we can get upthrust on this object is equal to the difference of reading. I will consider kilogram value without changing. It is 0.4 kilograms. It is the upthrust. And I will convert it to Newton. It is 4 Newton. Normally we are giving upthrust as a force, therefore we have to give it in Newton. And when immersing this object, we know that upthrust is acting on this object and there is a down thrust on corresponding liquid. It means down thrust on water. According to Newton's third law, action and reaction. Therefore, sum of these two readings should be increased by 4 Newton. Then we can write Rx dash plus Ry dash should be equals to initial readings 1 kilogram plus 1 kilogram, 2 kilogram, 2 kilograms, it is 20 Newton. And now it should increase by 4 due to the down thrust acting on water. And we know that Rx equals Ry. Therefore, we can get Rx equals Ry. 20 plus 4, 24, divide by 2, 12. 12 Newton. It is 1.2 kilograms. When finding reading of balance, we have to give it in kilograms because of it reads kilogram value. If the brass is made of copper and zinc of densities 9,000 and 7,000 respectively, find the mass of zinc in the block. The density of water is 1000. Right, now we can get mass of block. Mass of block is zinc mass plus copper mass. Zinc mass plus copper mass. We know that total mass is 1.2 kilograms. And we know that we have to find the zinc mass in the box. Then I will write this one without any change, zinc mass. And we have to substitute copper mass. I will use another method. We know that density is mass divided by volume. Then mass is density into volume. Density of zinc 9000, volume V zinc plus density of copper 7000 into volume of copper. Now it is the first equation. Then I will consider upthrust. When considering upthrust, we can write V rho G is 4 Newton. This V volume is total volume of the block. Total volume means zinc volume plus copper volume. Now we have to substitute density of water 1000 into 10 equals 4. Then we can write zinc volume plus copper volume 4 into 10 to the power minus 4. And I will subject copper volume from this equation. 4 into 10 to the power minus 4 minus zinc volume. Then we can substitute this volume to the first equation and we can find the zinc volume. Then we can write from first equation 1.2 equals 9000 V zinc plus 7000 V copper is 4 into 10 to the power minus 4 minus V zinc. Then we can find zinc volume in the corresponding block. 1.2 equals 9000 V zinc minus 7000 V zinc. It means 2000 V zinc plus 10 to the power minus 4 into 1000, 10 to the power minus 1, 7 into 4, 28, 2.8. Now, I have considered opposite thing, densities. Zinc density is 7000, copper density is 9000. Then, this one is 7000, this one is 9000. Now we can obtain minus 2000 V zinc. 9 into 4, 36, 3.6. And we can obtain 2000 V zinc equals to 3.6 minus 1.2, 2.4. Divide by 2, 1000. Divide by 2, 1.2. Zinc volume is 1.2 into 10 to the power minus 3 cubic meters. Now we have to find the zinc mass. Then we can get zinc mass density equals mass divided by volume. Mass is density into volume. Density of zinc 7000 Volume 1.3 into 10 to the power minus 3. Uh, 7 into 12, 84. It is 8.4 kilograms.